Hello guys, welcome to Self Help Maths Academy. Today let us continue with some more examples on the SVD. So here find the singular value decomposition of this given matrix. So for this, as we know, we will start with A transpose, composition of A transpose into A. So A transpose into A will give us this matrix. Okay, so since A transpose into A, if you observe, it is clearly a diagonal matrix. So therefore eigenvalues of the diagonal matrix will be the diagonal elements. So here clearly lambda 1 is equal to 9 and lambda 2 is equal to 1. So these are our eigenvalues. So these are the diagonal elements. Now we need to find out the corresponding eigenvectors. So for lambda 1 equal to 9, we know that for A transpose, the matrix looks like A transpose into A should be equal to 9 into X. This implies A transpose into A minus 9I. Okay, this, if I write, let me write this as into X. Okay, let me write this as I'm taking the matrix A transpose into A times of X equal to 9X. So therefore A transpose into A minus 9I X equal to 0, or in other words, it is A transpose into A minus 9I augmenting this with 0. This should be our matrix. So let us start with this one. So what is our A transpose into A? That is 1009. So it is 1 minus 9, 0, 0, 9 minus 9, augmenting this with 0. So this gives us, this is negative 8, 0, 0, 0, 0, 0. Alright. So clearly if you observe here, our x2 is free. So from R1, I just take that negative 1 by 8 times of R1 for a simplification purpose. So that I'll get it 1, 0, 0, 0, 0, 0. Okay. So if we write it as a solution, it is simply x1 equal to 0 and x2 is free. So since x2 is free, if I write it as a solution, so x is equal to x1, x2. This is equal to, where x1 is 0, x2 is x2 since it is free. Therefore, this I can write as x2. If I write, this will be equal to 0, 1. Hence, with respect to lambda 1 equal to 9, we got our vector. Let me write v1 as 0, 1. So this is our vector. Okay. Now similarly, for lambda 2 which is equal to 1. Okay. For lambda 2 which is equal to 1, we have to find out the eigenvector. That then again start with A transpose into A times of X is equal to lambda 2 is 1. So 1 into X. This implies it is simply A transpose into A minus 1 into I, that is simply I times of X equal to 0. In other words, it is A transpose into A minus I, augmenting this with 0. So what is our A transpose into A? So A transpose into A is 1009. 1009, as there will be, if you see, the only the from the diagonal elements, I have to subtract this one with 1. Okay, so augmenting this with 0. All right, so this matrix we will get as 0, 0, 0. This is 0, 8, 0. What we do is just simply from R2 we take 1 by 8 times of R2. We get this as 0, 0, 0, 0, 1, 0. So I think simply what I'll do is R1 and R2 I interchange. Not necessary to do that, but still for a 0, 1, 0, 0, 0, 0. So clearly our x1 is free variable. So if you write it as a solution, your x2 is 0 and x1 is free. Okay, so therefore we write it as a solution. So x is equal to x1, x2. So here x1 is free. Let me write it as x1, x2 is 0. So therefore if I take x1 out, it is simply 1, 0. So therefore for lambda 1 equal to 1, we got a vector v2 as 1 0. So these are our vector. So hence now we can construct v. So for construction of v, that is v1 v2, this is equal to our v1 is, let me see our v1 is 0 1, v1 is 0 1 and v2 is 1 0. So this is our v, the construction of v. Okay, now we have to construct sigma. So we have to construct the sigma, the big sigma. For that what we need is, we need d. So as we know, our sigma 1 is square root of lambda 1, which is equal to square root of, if you see, 9, that is equal to 3, and sigma 2 is square root of lambda 2, which is equal to square root of 1, that is equal to 1. So we have got two singular values, 3 and 1. Hence let us construct the sigmas. As you know that sigma is also of order A. Since A is of a 2 cross 2 order, so our sigma is also of a 2 cross 2 order with 3 0 0 1. So here clearly you observe, this is your sigma 1 and this is your sigma 2, and this is the order is 2 cross 2. So we have constructed here sigma and v. Now we are left to construct u. So for u, you know, to construct u, we want what? We want the important entities. We want a u1 is a v1 upon sigma 1 and u2 is a v2 upon sigma 2. So what is our a? Let us calculate a into v1. Our matrix A is given by, what is our starting matrix? 1 0 0 negative 3. A is 1 0 0 negative 3 into v1, that is 0 1. So this will be equal to 1 times of 0 plus 0 times of 0. Since it is 2 cross 2 matrix and this is 2 cross 1 matrix, the resultant matrix is of order 2 cross 1. This is again 0 into 1 and negative 3. This is simply 0 negative 3. So this is our A v1, which is equal to 0 negative 3. Similarly, let us find out A into v2. Our A is 1 0 0 negative 3 into v2. v2 is 1 0 1 0. This is equal to 1 plus 0. This is again 0 plus 0. So simply it is 1 0. So this is our AV2. You got AV2 as 1 0. So therefore also we know that our U1 is A V1 upon sigma 1. So our sigma 1 is already 3, right? So 1 upon 3 into AV1. AV1 is 0 negative 3. So this gives me, this is 0 minus 3 by 3, that is negative 1. Okay. Similarly, our U2 is AV2 upon sigma 2, which is equal to sigma 2 is 1. So 1 by 1 into AV2 is 1 0. So 1 into anything, it will be 1 0. So therefore we can construct our U by U1 and U2. This is U1 and this is U2. Okay. So we have constructed U also. This is of order 2 cross 2 now. So therefore let us write finally our A as U sigma V transpose. So our U is 0 negative 1 1 0 and sigma is 3001 3001 and V transpose, because we are our V is 0 1 1 0. So it is like the symmetric matrix, we still get 0 1 1 0. So this is our A in SVD. Okay. So this is one of another example where we have taken 2 cross 2 matrix to check how the SVD works. So this is all in this video. Maybe in the next video we will take up the next examples. Till then, take care guys.